Okay, good evening. So I wanted to give a tutorial today that kind of help explain how to transfer an implant's information, an implant's location out of Blue Sky and into exoCAD so that pre-surgical parts can be made for the patient to be delivered at time of surgery. So in this instance, it would be like an immediate provisional that you're going to load at time of surgery or perhaps at stage 2 after integration occurs. And the question is how to get the digital information of this implant's location out of Blue Sky into your laboratory. Now, if you're able to use Blue Sky natively and stay completely within the Blue Sky software, and you don't have to send this out to a laboratory, um, then this workflow is really not going to speak to that. The issue is that not all implant systems are able to do that. So there are some library systems within Blue Sky that allow you to design your crown completely within Blue Sky through a tie base and essentially export your crown in the crown bottom like form of the tie base, and then you get out your crown file and you glue it onto your tie base, and you essentially are able to accomplish the same goal. I want to be able to export a crown out of Blue Sky, glue it to a tie base, and deliver a provisional at the same time of surgery. But the issue is it's kind of a library permissions issue. So not all implant companies have released their libraries or allow for this workflow to occur. So some of us aren't able to use that native Blue Sky Bio crown workflow, and we have to step out of Blue Sky and send it to our lab. So that's really what this tutorial is about. Now, for us in our practice, we place a lot of 3i Biomet implants. So this is going to be a pretty 3i Biomet centric tutorial, but this workflow and this concept, I believe, applies to a lot more brands and is a lot more universal. So that's why I wanted to share it. Okay, so here is our patient. He would turn off the wax up here, so you can see the tooth is broken off at the gum line. This is our implant placed. This is a 3 by 13 millimeter implant. There's our wax up, and I want to be able to make a provisional for time of surgery. So if we click on our implant tab, since we're using a 3i Biomet implant, the implant system, the surgical kit is actually within Blue Sky, which is something I really like about this implant system in particular, is because the surgical kit is totally within Blue Sky. That makes, drill reports and all of those things that kind of go along with guided surgery is really integrated well. And for those of you who are placing other implants and you have, your guided kit within Blue Sky, this is all going to make sense. So the issue is, though, with 3i implants or implants that don't have their libraries unlocked, if I go to abutment and I click on replace and I click on select abutment, the list that we typically see that some of us maybe have seen is not here. There are no stock abutments here, and it's because of, I think, like a licensing issue between the implant manufacturer and Blue Sky and all of the stock tie-based libraries that are on there. So surely a lot of implant systems are going to have sort of this problem. So we're going to press cancel in this instance. So what I have to do is, even though I'm planning a 3i implant, and usually what I do is we complete the plan. We're going to completely make the surgical guide. So we're going to completely design the surgical guide and export that. And now what I'm doing is basically outside of that workflow. So now what I'm going to do is I'm actually going to get out of 3i, and or whatever implant system is not allowing you to do this, and I'm going to choose a more generic implant system. So I'm going to click the drill kit. I'm going to get out of the company's drill kit. I'm going to go to custom kit. And I definitely have to acknowledge my colleague, Dr. Peter Barnt, who showed me this process, and I'm passing it along to hopefully anyone who finds it helpful. So now I've changed our drill kit to custom kit. Now we're going to replace our implant. And for me, I want to choose an implant system. Obviously, that's not the implant system that's not allowing me to do what I want to do, but I want to choose an implant system that I'm comfortable with, that I understand the sizing on, that kind of makes sense. And for me, what I do is I go to Blue Sky Bio, I scroll down here to Nobel Replace, and I do that because all of the diameters are all really similar. Both of these implant systems have, a 3.5 or 3.4 millimeter diameter. They all have a 4 millimeter diameter. They all have a 5, and they all have a 6. Now, one of the really nice features about Blue Sky is no matter what implant system I change it to, no matter what diameter I change it to, the location of the implant's platform never changes. So I can switch back and forth between multiple implant systems, and essentially my implant platform doesn't change. And that's the key here, because when I attach a scan body to this implant system, I want it to equal the same platform location as my surgical guide is defining, right? Like my surgical guide is defining where my implant's going to go and the level of my implant platform, and that can't change in this process, and essentially it doesn't. So that's a good thing. Okay, so we're going to select the implant system that we're comfortable with, and then we're going to click on abutment, and now we have this full list of stock abutment libraries that are available to us because we chose a more generic implant system. And what I'm going to click on here is desk scan body, and this is the scan body in 3 dimensions, and you can see this flat part, and we're going to press OK. Okay, so here's our scan body now in place. Let's turn off some surfaces. So I'm going to turn off our wax up, and I'm also going to turn off our scan body itself. So here's the patient's original presentation. This is their jaw scan. We're going to turn on the scan body, and this is essentially defining the location of the implant right here. Now, it's rotated in some way, however the implant was rotated before, and then this is key. We want to rotate this scan body in a certain way, and this is where you're going to need to integrate or communicate or sort of do a little bit of legwork with your laboratory and your exoCAD software to make sure that whatever you're doing here is actually aligned with the libraries that your exoCAD software is using. And I'm going to sort of show you what I mean by that better, because that's a hard one to explain. So I'm just going to kind of explain what we do. So I'm going to unlock this implant. And so in our implant system and in our exoCAD libraries, I know that the flat part of this desk scan body equals the flat part of the hex of the implant system that we're using. And I want that flat part of the hex to be positioned straight out to the facial, just like that. And you can tweak that a little bit if you don't like it, but you basically want the flat part of the implant's hex facing straight out to the facial. In this implant system, there's an obvious reason for that, and that is that the surgical components, the fixture mount for the implant, has all of these notches, and all of those notches correspond to the flat part of the hex. So a surgeon is able to align with the implant's fixture mount is able to align basically where the flat part of the hex is. And so I want our digital plan to equal that. So I know that the surgeon's going to place the flat part of their implant straight out to the facial. And so I'm going to position our scan body the same. That way, the digital plan and whatever is happening in real life in surgery are almost identical. There may be a few degrees of difference that we have to tweak at time of surgery, but essentially the digital plan equals, future reality of the future implant surgery. Okay, so now all we do, let's relock that. Now all we're going to do is we're going to export this scene basically right here. And what is this? This is essentially an intraoral scan. So if you did an intraoral scan with a scan body, a digital impression coping, this is what you're going to get. This is what you're going to send to your laboratory. They're going to use whatever laboratory software they're going to use, and they're going to send you back a crown. And that's essentially what we have here. So at this point, we go up to File, and we click on Export Data. And we want our implant abutment, which is the desk scan body, to be clicked. We don't need the implant STL turned on, so we can turn that off. If you had any nerves selected, you'd want to unclick those. And then the only thing we want is our edentulous jaw scan, kind of in this case the patient's original jaw scan. So if you had a patient that had the tooth present, you would want to digitally remove that tooth, or have your lab do that, because you basically want an edentulous situation right here, so you can have a scan body where the tooth used to be. Now, by default, this is usually selected, export separated files to a folder. So what happens if that's X'd, if that's selected, it's going to export the abutment or the desk scan body separately and then export the jaw scan separately, which we don't want. We want both of these two things together. So we're going to unclick export separated files to folder. We're going to click on export, and essentially what we get is we're going to get something very similar to this. So this is a patient's jaw scan. This is the desk scan body with the flat part of the scan body facing straight out to the buccal. And so in our implant system, I know that the flat part of the hex of the future implant is going to be facing also straight out to the buccal. And that's it. This gets sent to the lab. So this image gets sent to lab along with, let me cancel this out real fast. So these are the two files that I'll send. So I'll send this exported STL file, and we'll also send this exported STL file, which is essentially the patient's original scan, or perhaps with the tooth digitally removed. And then we'll of course send the lab the lower jaw, or the antagonist. Now, I wanted to get into what I was talking about, making sure that your desk scan body is aligned to your implant hex. So in exoCAD, when you load up this desk scan body, you're going to be using a library file, that scan body library file, and that's going to equal whatever tie bases you're utilizing, or if you're actually going to be milling the geometry of the implant, like the hex or the trilobe of the implant, that scan body is defining where the position of the implant platform is, and it's also defining the rotation of that hex, or the rotation of the internal geometry of the implant. Now, that's something you have to work out with your exoCAD vendor. So for us, what we did is we talked to our exoCAD vendor and we said, this is what we're trying to do. We want to utilize this desk scan body that we can get out of Blue Sky, and we want to have it work with the tie base libraries and the tie bases that we use. And so they made that happen. And so essentially this is the scan body that we use, and you can see that the flat part of this hex is aligned with the flat part of, or sorry, I guess the flat part of the scan body is aligned with the flat part of the hex. And that doesn't just like randomly happen. So this is something that, you know, you have to go to your laboratory and say, hey, this is what I'm trying to do. And I need to make sure that if I export a desk scan body, that it's aligning to the flat part of the implant hex, you know, or whatever system you're using, like however that aligns with the surgical kit, however that makes sense to your workflow, you just need to communicate that to your laboratory or to your exoCAD vendor so that you can essentially create this same kind of concept within your workflow. So hopefully that makes a little bit more sense. Basically, when we choose the desk scan body library, it puts the implant platform and timing exactly where it's supposed to be, exactly where the surgeon is going to be placing it, approximately. And we can now make a crown from this information. We can either make the crown on a tie base, or we can design the crown straight to the hex of the implant. And you're ready to move forward from there. And so we'll just bring it back to Blue Sky here. So essentially this is a Blue Sky to exoCAD workflow that allows us to get, you know, a pre-surgical component like a provisional out of Blue Sky and ready for surgery. All right, thank you. I hope that was helpful. And if you guys have any questions or comments, definitely write them on the comments below, and I will get back to anybody who writes something. Okay, thanks.